Hi everyone, we're just preparing. We'll wait for a few of the stragglers to come in, and in a few minutes we'll be on the way with our webinar. If you've just joined, we're just waiting a few minutes to make sure that everybody is joined in before we can start, and then we'll be on our way. Right, 2 minutes in, I think we'll get started. Welcome everyone to today's webinar, and thank you for joining us. My name is Alison Renwick. Today's webinar is a second of series of best practice webinars that Softtech will be running. These are designed to help you grow your business. We would like these webinars to be interactive, so I encourage you to please put your questions at any time in via the GoToWebinar questions window. We will answer these at the end of the webinar. Chris Dowsett will be joining us as today's speaker, and he'll be showing you the automated shop drawing generator. Chris is a V6 implementation engineer here at Softtech. He has worked with Softtech for over 10 years in North America. He's worked on many different V6 projects during that time, and he has over 20 years of CAD experience behind him. Thanks again for joining us, and I hope you enjoy our webinar. Over to you, Chris.
Okay, thanks, Alison. Okay, welcome everybody. Looks like we've got a pretty good turnout today, so thanks everybody for coming. So today we're going to be looking at a way of automating shop drawings using Taiga macros in V6. A lot of the functionality we'll be looking at today was developed for Architectural Window in New Jersey, and they've been kind enough to let me show it to you today. So we're going to be looking at a few of the concepts and show you some of the things we've been able to accomplish. So thank you everybody at AW. So I'm going to go ahead and turn off my camera so that you get a bigger view of what we've got going on here. Let me just figure out how to turn that off. Okay, so what we're going to cover today. Okay, so we're going to start by explaining what Taiga is. We're going to look at some sample shop drawing output. We're going to go into a little bit of detail about different parts of the drawing. We'll move on to how we're able to automate the layout. And then we'll look at a couple of the challenges we had, how we're able to overcome them. And then finally, we'll talk briefly about how you can get started with Taiga if it's something that you feel could be useful. So Taiga, so what is Taiga? Taiga is a software development platform that was designed to work with DWG and DXF files. It used to be called DWG DirectX, so for those who have installed V6 in the past on their machines, they probably remember seeing the DWG DirectX installer popping up when they first started V6. Taiga is accessible through the V6 macro language, so if you know V6 macros and you have some knowledge of AutoCAD, you can take advantage of Taiga to create drawing reports, shop drawings, things like that. So it's developed by an organization called the Open Design Alliance. They have over 1,250 members, including Softtech, and some of its members also include companies like Adobe, Oracle, Bentley Microsystems, Intergraph. So it's got some backing from some pretty big names in the software industry. Okay, so I'm going to take a quick look at a sample of the output that we've been able to achieve. Everything that you can see here was generated by a macro in V6. There was no editing required. It was just one click and the macro generated both a PDF and a DWG. So, so the drawing contains a lot of different information about the window, and anything that can be queried from the database or determined from the model in V6 can be added to the page. So in this example, we have, for instance, we have a section for paint finishes, we have a section for balances, screens, etc. And the idea was that we would create a separate function for each one, which gives us the ability to turn things on and off as required, and also control where they appear on the page. This also has the added benefit that we can easily add additional information later by just developing a new function to cater to that requirement. So I'm going to talk a little bit more about some of the items on the page and how we created them. So just to start off, we're going to look at the elevation drawing. Okay, so the important thing here was really just to create a clean, clearly dimensioned drawing that contained all the information that the guys in the shop needed to put the window together. So this drawing was drawn completely from scratch by interrogating the model in V6 and determining which parts needed to be drawn. We do this by tagging assemblies in the model, and this stops the drawing from becoming cluttered with unnecessary items. So, if we find an assembly for a glazing bead in the model, we don't necessarily need to draw that to clearly illustrate, the actual frame that we have in the quote. So by tagging the items, we get to turn things on and off, and really just draw what's absolutely necessary to create a clear elevation. We also added the ability to label all the parts. In this case, we are adding both their part codes and also their cut lengths. We also really wanted to be able to add custom graphics. Sometimes it's useful to add graphics to, denote a certain property of the frame, what type of glass is in the frame. So you can see as an example here, we've added a hatch pattern to the lower sash, and that indicates that there is a louver in that sash. The dimensioning also was designed to cater to both what I call frame-based dimensioning for a product like this, where you might want to dimension both the frame and the nested frames, and also what I consider to be light-based dimensioning, which for instance would be where you're effectively dimensioning lights to show the center of a mullion, for example. This could also be expanded to do things like DLO dimensions. Any dimensions that are actually in the model can be determined and added on, and these are added as true AutoCAD dimensions. So therefore you get a lot of control over your dimension styles, how you want things to appear, and pretty much makes it look very much like you would draw it if you were actually sitting in front of AutoCAD drawing this window. So overall, the results for this have been pretty good. So next thing, cross sections. Okay, no shop drawing would be complete without cross sections. This was actually created using the existing shop drawing generator functionality in the macro language. But one of the things we've had added recently is a new macro exposure where we can determine all of the cuts that have been added to the frame. That way we can then create a drawing for showing any of the cuts that we want, and we can position them anywhere that we want on the actual drawing. Okay, glazing info. So the main goal here was to be able to report some of the complex glass configurations that we can achieve using the glass interface. So for those that aren't familiar, the screenshot on the left is Softex glass interface. It was something that we developed to allow you to configure some pretty complex glass makeups. So I had to come up with a way to present the information clearly and be able to customize which glass properties get shown and which ones don't. You may not necessarily want every attribute that the glass interface writes to showing on the shop drawing. So we added a way to selectively pick which options you want, which properties you want to be displayed, and also format the way in which they're actually displayed on the drawing. So you'll see there that we can also add prefixes and suffix to things. So if we look over here, for instance, you'll see that there's an EXT. That's really just a suffix, sorry, a prefix that we put on that property, just so it denotes that this is an exterior piece of glass, an exterior layer. It just makes it more clear for the guys in the shop when they're trying to glaze the window. We also added a way to show which lights get which glass configuration. Pretty important. We don't want the wrong glass going in the wrong light. So on the previous elevation drawing, you may have noticed there was light callouts. So the lights were numbered 1 and 2, the number 1 being the bottom light, number 2 being the top light. So we also label those here, so you can see on the actual properties here that we're showing which light goes into which glass goes into which light, and it also shows the size. So one thing to note is that the layout of the glass properties that was shown here was designed to be very compact, and it was designed to fit in a letter or A4 sheet. But this could easily be put into a table form, like a typical glazing schedule, which pretty much leads me into the next slide. So the next one was that we looked at here, want to look at here is custom schedules. Okay, so we wanted the ability to add custom schedules to the drawing. And Taiga supports AutoCAD style tables, which makes this quite a simple process. So these can be anything you want, really. They can, this one here is a cut list. It could be a glass schedule like we just talked about. Pretty much anything that can be queried or determined from a macro can be added to a schedule like this. And because we can determine the size of the content in each cell, we can also automate the actual row and column sizing to make sure that everything fits. So in this example here, the drawings are, we know the size of our cells, the drawings are scaled to fit inside the cell. For the actual part codes there, as we add them, we determine the size of that piece of text, and we adjust the column size accordingly. So that way everything always fits nicely inside the schedule. So like I said, anything that can be queried or determined from a macro, we can put into an actual AutoCAD style table. So layout automation. So this was probably one of the most important parts of making this whole solution work. No two shop drawings are ever the same. So your layout has to be flexible enough to cater to a wide range of products and different configurations. So you'll notice on these two examples that the positions of each part of the drawing is different. So on the one on the left, which is the double hung window, you'll see we have the schedule over to the right, we have the elevation drawing over to the left, and so on. And obviously for the slider here, everything's been moved around to make it fit the page. And the reason for that obviously is because one frame might be longer than it is tall, or it might be taller than it is wide, for example. So our layout needs to change depending on the frame that we're displaying on the drawing. There really is no one size fits all solution for dealing with drawings like this. So we came up with a parameter driven layout, and this basically allows us to define as many custom layouts as is needed. And then the macro just determines which layouts will fit this particular frame the best. So an example above, the sliding window is wider than the double hung, so everything gets positioned differently. In this particular case, we also added an aspect ratio as one of the parameters for the layout. Because the double hung window there may be wider than it is tall, or the slider may be taller than it is wide. So we actually need maybe more than one layout per product type in this case. So I'm going to jump in quickly and show the next slide and show you just how we're actually achieving that. So here's a screenshot of a lookup matrix. And it really just shows how we define where we're going to draw each item on the sheet. So each item, and when I talk about items, we're talking about here, like we have a, we have a finished section, we have week doors here, we have a hardware schedule and so on. So we literally define where each one of those items will appear on the page, or if they get shown at all. So here's the lookup matrix that actually contains all of these parameters. Okay, so if we look here, this is actually this is one of Architectural Windows sliding products. It's a 6500i. So these tabs down here in this lookup matrix are two different layouts. So what we did here is we created a 6500i wide and a 6500i tall. So we can have a different layout for a wide slider. If we have a situation where we've got a 2-light slider and it happens to be quite tall, we can switch to a different layout and position everything on the page accordingly. So if I just quickly look through the contents of this lookup matrix, each element is defined as to whether or not it's required on this particular layout. So in this case, we've got finishes and we've got a yes, so that part will get added. Window mark, which is just the call out of the window up here. So that there determines whether or not that gets added to the window, to the layout. This determines whether the hardware schedule gets added. And then further down in the properties, you'll see here we have a block X and a block position Y. Okay, now those, for people who are used to working in AutoCAD, those are paper space coordinates within your layout. So in this particular case, this is an 11 by 17, also known as an A3 layout. And those positions there determine where on the page that this will get added. So for the finishes, for instance, we have 3, 2.5, which means that it will, from the bottom left-hand corner, it will get positioned 3 in and 2.5 up. Okay, and by having this flexibility with where we place things, we can very quickly find, the best position for everything for any particular product. So it doesn't really matter how varied your products are. You can really program in more parameters if you feel the need. In this particular case, we're just dealing with 2 parameters. So we're just dealing with the actual product type itself, so that we can get a pretty good idea of what the frame is going to look like, and what the actual aspect ratio of it is. So we can cater to a tall slider and we can cater to a wide slider. Obviously, some things like fixed windows, projected windows, storefront, shop front elevation, things like that, you may need to add in some additional parameters to cater to it. And there's nothing saying that really this couldn't be developed further for very wide elevations where the elevation gets sliced up into smaller pieces, and then you have continuation marks, from page to page. So as it's all completely macro driven, how you add things to the page, how you lay out your drawings, is entirely up to you. And it also means that the drawing gets to, it looks how you want it to look. A lot of my experience working with CAD drawings is your CAD drawing is part of your business. It's almost part of your branding. You generally develop your own text styles, your own dimension styles, and often when you're sending those, and sometimes you're sending those drawings off to customers, so they need to look good, and then they need to represent your business. So this gives you that capability. What we actually did here was we created a template drawing. We loaded in the text styles we wanted, we created the dimension styles that we wanted, and so on, and we used that as our starting point. So so you have complete flexibility with how you lay it out and how it looks, and I think that is one of the very important aspects of this. Okay, so going to move on to a couple of the challenges and the solutions that we had. One of the big things here was overlapping text. You can never really predict how much it really needs to end up on the drawing. A good example that we're showing here is a hardware schedule. Obviously, depending on the product and the options that are picked, you really don't know how many items are going to be in that hardware schedule. We do control it in very much the same way that the elevation drawing is drawn. We tag the items that we want to appear on the hardware schedule on the drawing. We obviously don't want every single screw, nut and bolt, everything to appear on there. So this gives us a way to filter that list and just show really the necessary items. Okay, so the hardware schedule obviously can grow. You won't know from product to product or quote to quote, you know, exactly how many items are going to end up in your hardware BOM. So you don't know how much space the schedule is going to take up on the page. So in this example here, we've configured our weep doors to appear directly below our hardware schedule, but we don't really know how much space we're going to need above it. So for anyone who's familiar with AutoCAD, particularly any kind of AutoCAD programming, we have the ability to use what we call selection sets. So anytime we place something on the drawing, we can determine what else is occupying that space. So in this case, one of the solutions we came up with was to place the item. So in this case, I would place the text for the weep doors for the header, and the underline here is actually just an AutoCAD line that was added. And then we run what we call a selection set using a crossing polygon for the AutoCAD people here. And then we just determine how many entities ended up in that selection set. So in this case, we should only have 2. If there's any more than 2 items in the selection set, then we obviously were overlapping something. We've put our weep doors on top of another item. So what we do is we pass a function that says if you find yourself sitting on top of another item, move in a particular direction by a predetermined amount. So I could say in this case, I still want it to align on the left. So we want to move down, and we'll move down by maybe 1/4 of an inch. So the function just really runs recursively. It will move the item down. It will then run the same selection set and determine if it is now in clear space. If it keeps on finding that it's still overlapping something, it will just keep on moving until it finds itself in clear space. So in that point, then it basically just drops down until it's not overlapping anything and is perfectly readable. So the other challenge we had was text scaling, and this is something that's quite a complex problem. We're often trying to add text to something, and depending on the size of what we're trying to label or where we're trying to fit that text in, we may not have enough space, and we end up with things overlapping. So one of the things that we came up with or was really just to think of, what are we associating that text with? So in the case here, we have effectively some extrusion codes that are labeling the bottom of this sash. Okay, and it's quite a narrow window, so the text doesn't actually fit inside the space. Okay, but what we can actually do once we've added that text to the drawing is we can determine how big it is, or how much space is taken up on the drawing. So, and because we've associated that with the bottom rail of this sash, we know the bottom rail of our sash is 33.563 inches long. The drawing is drawn to scale in the actual drawing in model space. So we know we've got 33.563 inches to play with in this case. So we can determine the width of our text and determine if it's going to fit within that space. And then if we determine it is not going to fit, then we have 2 ways of dealing with it. We can either reduce the width factor of that text, something which I've always done in the past. But one thing to bear in mind is that once you start reducing width factors down beyond, say, 0.5, then the text becomes unreadable, at which point, it's just no good. So at that point, so what we do is we calculate what the width factor would need to be to fit in that space. If it goes below 0.5, then we can reduce the text height and then recalculate again on the width factor. And then really what we end up with there is a method to actually bring this text down to a size that fits inside its own space. So this was actually quite a challenge, just to cater to all of the different scenarios. It's something that still occasionally comes up, and we're continuing to develop it for Architectural Window to make sure that they don't have to do any editing of the drawing afterwards. So, and that's pretty much the whole solution we've come up with. So I'm going to move on to this, which is getting started. So if this is something that's obviously of interest to you, if you're looking to do any kind of drawing reports, we can offer some introductory training in Taiga, certainly help get you going. If you're already good with macros and things like that and AutoCAD, then most of it will be quite logical to you. So we can do some introductory training just to get you on the get you started, so you don't have to deal with some of the same hurdles I had to. And then obviously the other thing is we can also look at your database and develop a custom drawing solution for yourselves as well. So that is about it. So thanks everybody. So if anyone's got any questions, feel free to type them in the box and I'll do my best to answer them. Okay, does anybody have any questions? Okay, let me just Well, I have a question from Rosaldi asking where's the lead guitar intro. So I will talk about that one privately. Okay, somebody asked how do you access the V6 glass interface. This is something that's it should be available on our FTP site. It does require some setup, and it deals primarily with quote IGUs. So if quote IGUs is something that you're using right now, then it is definitely something that maybe you could benefit from. But basically the glass interface, if it's something that you're interested in using, then it would be best to sort of talk to whoever you normally deal with at Softtech and arrange to get an install and explain how it gets set up. So, okay. What else do we have here? Can you separate the elevation? Yes. Basically everything on that you can see on the page is drawn by a separate function. So if you wanted just an elevation drawing, you can just have that, and you can push it out again to PDF, or you can just push it out to DWG, DXF, anything you want. So if you wanted to use it as a starting point for something bigger, or whether you just wanted to bring it into another drawing as a block, that's also something that you could do. Okay, so I'm having trouble with meeting here. Just bear with me 1 second. Okay, sorry, I'm just having trouble seeing some of these questions in here. Okay, so you also asked if the sections can have their separate positions and scales. Yes, one thing I didn't show, just due to really time constraints, the cross sections, as and the elevations are all positionable through a different lookup matrix. And then what we actually do is we specify a viewport size. You can have that stored in the lookup matrix. So you have a size, a width, and you specify the center position for the actual viewport. So the drawing gets drawn into model space and then is zoomed into that viewport. So as long as you know the size of the drawing that you're creating, which is pretty easy to determine, and the size of the viewport, then obviously you can determine your scale. Pretty much the same way you would do it as if you were drawing it manually. So. Okay, so what else do we have here? Okay, when is this available? Obviously, Taiga, it's available in V6 now. It's something that is has been, like I said, has been in V6 since version 3.4. But it is a macro-driven solution. So this was actually something that we developed for Architectural Window in New Jersey. We worked very closely with them to develop this. So really what we're showing is the possibilities, some of the concepts that you could use, but really it is a custom drawing solution. But really the beauty of that is you get exactly what you want. There is no kind of one size fits all. You get to develop it in any way you want. I've got a question. Can this be used on other Autodesk products, i.e. Inventor? Really, it's just developing a DWG and a DX or a DXF. So it's working outside of Autodesk products, to be honest. Taiga just supports DWG and DXF. But theoretically, anything that you create using it could be bought into Inventor as it is an Autodesk product. Okay, I've got some other questions. Will you be sharing sample code? Not from this solution. Like I said, obviously we can provide training, get you started, and show you how to do things. I'm planning to put almost like a utility macro together with some functions to help with the process. And then there's a question on costing. That's really just depends on how much you want it to do. It could be anywhere from a week's work to whatever you really want it to do. So it's quite a difficult question to answer. And what else do we have? Okay, which versions of this compatible with? Pretty much 3.4 onwards had 3.4 used DWG DirectX, which was later renamed to Taiga, and we have there is slight differences in the versions between 3.4, 3.5, and 3.6. So there may be some properties that are accessible, some objects that may not be available in 3.4. But I don't think it's changed too much. So pretty much anything from later 3.4 all the way up to 3.6. Okay, can we have callout balloons instead of text? Absolutely. This can draw pretty much anything that AutoCAD can draw. So if you wanted to develop a block with attributes for your callout balloons, you could do that, or you could just draw them as circles and add text to the center of the circle. So it's flexible on just about how you want to do it. Okay, someone said instead of a text on a drawing, can we show in a table list? Yeah, that was one of the things I showed. It does support AutoCAD style tables. So anything that you can query, anything that you need any properties that you can build up into an array and a macro, you can add into a table. can it generate a cut list for each individual component? For each single component. I'm assuming when you say each single component, I'm assuming you mean all of your extrusions, everything like that. Yeah, absolutely. You can look through the actual drawing model or the frame model in V6. You can break it down to individual extrusions, assemblies, pretty much anything that you can find from the model, you can add to the drawing. So. Okay, can you show fab cuts and fabrication drawings? If you can determine what they are and you have those drawings in a library somewhere, then there's no reason why those drawings could not be pulled in and loaded up as a block inside the drawing. So two ways you could look at that, two ways you could accomplish that is you could interrogate the model, determine where your reference points are, what milling preps you've actually got on those parts, and pull in the appropriate drawing from a library that you have stored on your machine or on your network somewhere. Another approach would be to do something very similar, but just to query the database to get your milling information that way, and then match up those milling preps with the correct drawing. So the answer to that is yes. But one thing that really I really want everyone to sort of go away with this is that this is it's a very powerful drawing tool. So anything that you can normally do in AutoCAD, you can generally do in Taiga. It's really just a case of working out what you need to show, and then it's just really just drawing in AutoCAD but programmatically. So someone asked if we can import structural drawings. Again, yeah, if you've got some way of tagging that in the frame, maybe through surrounding conditions or an attribute or something like that, something that you want to tag the frame with, then yes, you could also bring that in from a library of drawings. Okay, and Trevor Dartnell asked, when can we start? Whenever you want, Trevor. Okay, so I think that's about it. So if anybody has any other questions, feel free to email me, or we can have a Skype call or something like that. So I'd be glad to hear from just about anybody here. And that's about me over. So hand back to you, Alison.
Great, thanks very much, Chris. And we hope that you've enjoyed our webinar today on the automated shop drawing generator. Again, if you have any questions, or like Trevor, if you're wanting to get started, get in touch with us or your Subtext sales representative, and we can design and move forward from there. Great, thank you.
Thanks, guys. Everybody.
Thanks, Chris. Bye.